done with the graphical method, we will now proceed to the analytical method. We will start specifically with using the laws of sines and cosines. Okay, so the steps in vector addition using the laws of sines and cosines are the same as in the polygon method, except that instead of determining the magnitude and direction of the resultant vector by actual measurement, or they are computed using these laws. So you need to draw the polygon to represent the vectors for you to be able to make analysis. And while making analysis, you are of course going to use the laws, which are expressed in equation form. So the laws of cosines is expressed in the equation. Vector r equals the square root of the square of vector a plus the square of vector b minus 2ab, or vector a multiplied to vector b and then multiplied to cosine theta. You can also simplify this form into, or by squaring both sides. Square of vector r and this side right here. Okay, so when you square both sides, of course, this squared symbol and the square right here can be cancelled, making your equation become r squared, or vector r squared, equals a squared, or vector a squared, plus vector b squared minus 2 vector a times vector b times cosine theta. Again, theta here is a Greek letter used in representing an angle. Okay, now the laws of sines is expressed in equation vector a over sine theta equals vector b over sine alpha. Okay, so some of the variables here are not fixed, so they can still be changed, just like some other variables in mathematics, like vector A and vector B. Pwede pa na siya ma-usab. You can use vector F and any other variable. Same here with the laws of sines. You can change vector A, vector B, so as theta and alpha. These Greek letters here are again used to represent the angles. Now let's apply the concept of the laws in our example here. By the way, this example is using the same set of values used in the parallelogram method. I'm doing this for us to be able to find out whether or not we were able to have the same or come up with the same result using both the graphical and analytical method. Alright, so first thing you need to do in this technique or method is representing all of the given vectors by drawing again a polygon. That is to help you draw or make analysis. Alright, so let's start. Okay, so we'll start with F sub 1, or vector F sub 1, which is 4 newtons directed east. By the way, in analytical method, there is no need for you to use the measuring tools, or it's up to you. If you want a neat and like a good representation, then you can use your measuring tools para straight ang linya. But if okay ra ninyo if dili like perfect ang representation, then you can have it, or you can directly draw it. So we will start with F sub 1, that is 4 newtons directed east. I'm not going to use a measuring tool anymore. Okay, so this is f sub vector f sub 1. And then in polygon method, remember that the tail of the second vector is connected to the head of the first vector. So we are going to connect 6 newtons to the head of 4 newtons. That is northeast. I-estimate lang ang length. Kung mag-represent mo, yan kung nanglayo na kayo sa tinuod. So, 4, estimation lang. Alright, next is f sub 3. 8 newtons directed south. Then the resultant, this is f sub 2 and vector f sub 3. My God, it's so noisy. And then this one, last side is for the resultant vector connecting from the origin or the tail of the first and the head of the last vector. Okay, this is vector R. Okay, let me tell you that the laws of sines and cosines are only applicable or can be applied only when you are dealing with triangles. But since we have here, what we have here is a 4-sided polygon. The question is, how are we going to use these laws? That is part of the analysis. So what we are going to do is to form triangles. That is by dividing the polygon. So if you are going to divide a four-sided polygon, that would form 2 triangles. Alright, so if we are to divide this figure here, we can have it this way. Or we can also, or in this manner, we can have this first triangle and the second triangle, having this one as the additional side. We can also have this side here. So it's up to you which division you want to use. In my case, I would prefer this one right here because it is way much easier. Depende na sa inyong choice kung sa nga division inyong ganahan. Alright, so we will have this one. You can also try the other way or the other division you want to. Okay, so in this case, I have how many triangles? Actually, we only have one, and this one right here, the remaining is still a polygon, but it is still, we can still do it this way. So in this case, our first triangle is this one, f sub 1, f sub 2, and resultant r sub 1. That is the resultant of f sub 1 and f sub 2. We have here the subscript 1 to represent that this side here is not yet the final resultant. Our final resultant should always be represented by R only without the subscript. Para dili ta talang asa naman yung tinuod na final resultant or answer sa ato ang solution. So, let's proceed. Okay, so now we have our sub 1. After finding out the resultant of f sub 1 and f sub 2, we can already have the value for r sub 1, vector r sub 1, which can be useful when we find or when we solve for the value of the final resultant r. That is, r will be the resultant vector of r sub 1 this side and f sub 3, still forming a triangle. So we can apply sine or the laws of sines and cosines. So let's start. Now we will focus only on this triangle. Oh, later na ni second na triangle. Ayaw sa naguna-unaan. Alright, so first law that we are going to use is the laws of, or the law of cosines. That is useful in finding out the magnitude of this vector or this side right here. Alright, so we have r sub 1 or vector r sub 1 equals, we can use the square root of vector f sub 1 squared plus vector f sub 2 squared. But in my case, I will directly have this one. Vector r sub 1 squared equals vector f, kanina magsulat-sulat sa square root. Vector f sub 1 squared plus vector f sub 2 squared minus the quantity of 2 f sub 1 times f sub 2 cosine theta. Our theta here is not yet the final direction. So we can again represent that using a subscript. You can also use other Greek letters like alpha, beta, gamma, just like that. Okay, so next is the substitution process. F sub 1 is 4 newtons. Simply substitute. F sub 2 is 6 newtons. And then minus 2 times 4.0 newtons and 6.0 newtons cosine. Okay, this is now the question. What is the value of cosine? I mean, the value of theta sub 1 here. Or what does this theta sub 1 represent? Alright, so this angle here, I mean this symbol here, represents the angle opposite to vector r sub 1. Okay, now r sub 1 is here. The opposite angle of r sub 1 or vector r sub 1 is this one. How do we know the value of this angle? This is theta sub 1. Okay, in this case, we start doing the analysis. Okay, so as we know, f sub 2 is directed northeast. That is 45, exactly 45 degrees between north and east. Yan ang 45 man because right angle is 90. 90 divided by 2 is 45. Okay, so I'm going to put here an imaginary line or broken line to represent that this angle here is 45 degrees. Okay, so as what you know, or as what we have learned, an angle that is forming or that forms a straight line is equal to 180 degrees. Since we are looking for this portion right here, that means 180 degrees minus 45 degrees is 135 degrees. So 135 degrees is the value of theta sub 1. 135 degrees. Okay, now we will proceed to the performing of operations. Square of 4 newtons is 16 newton squared. Of course, the unit will also be squared. And then square of 6 newtons is 36 newtons squared. Minus 2 times 4 is 8. 8 times 6 is 48. Sakto ba? Right. 48 newtons squared. Buha na ka newtons. Cosine 135 degrees. Okay, in this portion, like what I told you in analytical method, you need a scientific calculator because of this part here. Okay, so later na. 16 plus 36 is 52 newtons squared. Minus, this time we will use the calculator because we need to multiply these terms right here before proceeding to the difference or the subtraction. Cosine 135 times 48 is 33. Negative 33 rather. Negative 33.94 Newton squared. Alright. So 50, that is 85.94 Newton squared. Then, okay, so since we are looking only for R sub 1 we need to get, or we need to take the root of each side. So square root of R sub 1 squared and square root of 85.94. And somebody, hey, wake up. Uy. Okay, so in this case, we are going to cancel square, and then 85, square root of 85.94, that is 9.3 newtons. Okay, R sub 1 is 9.3 newtons. Alright. Okay, now we have already the value of R sub 1, which is useful in finding out the magnitude of vector R. But before we proceed, since in finding vector R, we need the value of its opposite angle. That means we need to find out how much is this angle right here. Okay, how do we do that? That is by using the laws of sines. Expressed in the formula okay, now So what we need or what we are looking for is the value of this angle right here. We know already that alternate opposite angles are equal. That is, since this is 45 right here, its alternate angle is also 40. This one, from here to here, that is 45. Same as kani, 45. Since we are looking for the angle from here to here, we need to find out how much is this, or what is the value of this angle here. That's the time we use the law of sine. So this angle here can be represented by theta sub 2, since we have already used theta sub 1. Okay, so this is theta sub 2. Okay, so in this case, we have theta sub 2 is the opposite angle of f sub, or vector f sub 1. So we need to put vector f sub 1 here over, what's this? The angle we are looking for, sine theta sub 2. And on the other side is the magnitude is the side that has an opposite angle which is already known, just like vector r sub 1. The angle is known as 135 degrees. You cannot use vector f sub 2 kay ang iyang opposite is unknown man. We will focus on the angles that are already known. So this is sine 135 degrees. The opposite of this angle is vector r sub 1. Okay, right after, we will proceed to the substitution process. F sub 1 is 4 newtons. Sine, since theta sub 2 is still unknown, simply copy. R sub 1 is 9.3 based on our calculation. Sine 135. Okay, right after, or the next process is cross multiplying. So sine 135 that is 9.3 newtons times sine theta sub 2 equals 4.0 newtons times sine 135 degrees. Okay, sine 135 degrees times 4 is 2. Okay, so since we are only looking for the value of theta sub 2, we need to get rid of 9.3 newtons as well as this sine here. That is by dividing 9.3 newtons. We can do that by dividing 9.3 newtons both sides. So we can cancel it. And what's left is sine theta sub 2. So sine 9.3 is 0.30. Cancel ang unit. 0.30. Since we only need the value of theta sub 2, that means we need to divide both sides by sine theta sub 2. Okay. Sine here in the denominator cannot function only by itself. So we need to bring it up. Arc sine, it becomes arc sine because any variable from the denominator, when you transfer that to the numerator, its power or its exponent will become negative. Or if it has originally a negative exponent, it will also become positive if you transfer it to the numerator. Arc sine 0.30. Arc sine 0.30, that is 17.7 degrees. That means theta sub 2, or this angle right here, is equal to 17.7 degrees. When we add that to 45, we will have 62.71. That means the opposite angle of resultant vector R is 62.71 degrees. I'm going to check if it's right. 62.7. That's right. Alright, so we will proceed now to, or we can now proceed in finding out the magnitude of resultant vector R, since we know already the value of its opposite angle. Okay, again in finding the magnitude, we need to use the law of cosines. Since we are looking for the magnitude of vector R, and the lines or the sides involved in the triangle is f sub 3 and r sub 1, our equation will be in the form vector R equals, vector R squared rather, equals vector f sub 3 squared plus vector r sub 1 squared minus f sub 3 r sub 1 cosine opposite angle of vector R is 62.71. Okay, substitution process. F sub 3 is 8 newtons. R sub 1 is 9.3 newtons. And then 2 times 8 newtons times 9.3 newtons cosine 62.71 degrees. Square of 8 is 64 newtons. Square of 9.3 is 86 is 150.49 Newton squared minus cosine 62.71 times 148 newtons is 67.86. 150 minus 150.49 minus 67.86 is 82.63. That is r squared. Vector r squared is 82.63 Newton squared. We need to eliminate or get rid of this square here. We can do that by taking the root of both sides. Square root of 82.63 is 9.09 newtons. Okay, in that case, vector r has the magnitude of 9.09 newtons, or approximately 9 newtons. Okay, so we have already the magnitude. Next is, of course, a vector quantity cannot be a vector quantity without its direction. So we need to find out the direction of vector r by using the law of sine. Okay. Asa man ta mag-start when we are looking for the direction? Of course, we need to start always at the origin. Okay, with respect to the horizontal. Always with respect to the horizontal. Okay, that is, the direction of x of 1 is here. This one is the final direction. Again, we represent our final direction by the Greek letter theta. Okay, how do we know kung pila ni siya nga direction? Since we are calculating for this triangle here, the second triangle, we have already found out this angle, which is 62.71, and we need to find out this 1. Okay, for us to be able to know the value of theta here, we need to find out this angle coming from here to here. Line vectors of r. Okay, that is by using the law of sine. Okay, so the opposite for this one is this angle. We will represent this one as theta sub 3. Okay, so sine theta sub 3, the angle we are looking for. And sine, what's the other angle that is already known, present in the second triangle? That is 62.71, known angle. Okay, now we are looking for theta sub 3. In the numerator, that is the opposite side of theta sub 3, which is f sub vector f sub 3. And the opposite of 62.71 is vector r. Okay, we then substitute f sub 3 is 8 newtons, copy sine theta sub 3 equals vector r is 9.09 newtons we have 9.09 newtons times sine theta sub 3 equals 8.0 newtons times sine 62.71. So sine is equal to, hindi na ako i-show ang kuan na ang step. Basta i-divide na siya both sides by 9.09. Okay, wala na tayo space. Okay, so sine 62.71 times 8 is 7.11 divided by 9.09. That is 0.78 degrees. Now divide both sides by sine, and then sine becomes arc sine 0.8. That is theta sub 3 is equal to 51.46 degrees. Okay, 51.46 degrees. Since we are looking for this angle here, theta, we need to subtract 51.46 degrees with the value of this angle. How do we know the value of this angle? That is the sum of the total internal angles of a triangle is equal to 180 degrees. Since we have known already this angle and this angle, we simply have to subtract that. There's these angles to 180 for us to find out this one here. 180 minus 135 minus, okay, kanina angle is 17.7. We get 27.3. So kanisha is 27.3 degrees. That is 51.46 degrees minus 27.3 degrees is kanisha, kuhaan ani, ang nabilin is kaning. So 51.46 minus 27.3 is the value of theta. Theta is equal to 51.46 minus 27.3. That becomes 24.16. No, 24.16. Therefore, the direction of vector or resultant vector R is 24.16. So mani, between south and east. Not in the middle, or not perfectly in the middle. So we say vector R is 9.09 newtons directed 24.16 degrees south of east. is 9.09 newtons directed 24, approximately 24 degrees south of east. Alright, so this is already our vector r, or the value of vector r using the laws of sines and cosines. So as you can see, the direction is only 24 degrees. I think the variation is caused by the decimal places that is used in the calculation. Anyway, I will be accepting variations for the magnitude that is ranging, or for the variation of magnitude, I only accept variations of positive and negative 0.5. And for the variation of the direction or angle, I'm accepting positive and negative 3 degrees. So for example, the answer here is 9.09. Some others can get, let's say, 9.3. Or in this case, we have 9.1. If ato ni siyang i-round off. Others can get 9.3, 9.5, 9.6. So ang acceptable only is, let's say 9.1 is siya, plus or minus the variation of 5 or 0.5. Okay, I'm accepting values ranging from 8.6 to 9.6. That is plus or minus 0.5. And for the direction, I can accept values ranging from 21 to 27. Okay. Alright, so that is how you do the process in applying the laws of sines and cosines.